Okay guys, today, section 9.2, it says solving linear systems using the substitution method. Now remember, last night you used a graphing method and you probably came across some difficulties in finding that exact point. You know, sometimes the lines don't cross on with nice whole number coordinates, you know, right where two little grids meet. So it's hard to kind of guess where that point is. So today I'm going to show you a method that we don't have to guess. It works every single time, okay? So remember, a system of linear equations is just more than one linear equation, all right? So we've got two here. I'm going to rewrite them. I'll do x plus y is equal to 15. And then the second equation I'll write in blue. 4x plus 3y is equal to 38. Now, what you want to do with the substitution method is you want to pick one of the equations and get a variable by itself. So of course you want to pick the easiest one to get a variable by itself. Well, looking at these two, the red equation is super easy to get a variable by itself. I could get x by itself by subtracting y, or I could get y by itself by subtracting x. You know what, I'm just going to subtract y. It doesn't matter. I could get either one of them, but I'm going to subtract y. And the new equation that I get is x is equal to 15 minus y. Okay, now the reason we got a variable by itself is because now we found out what x equals. It equals 15 minus y. X is the same as 15 minus y. So I'm going to take that and I'm going to plug it into the other equation, 4x. So when I rewrite this one, it's going to be 4 times, not x, but what x equals, 15 minus y, plus 3y is equal to 38. Now I only have one variable in that second equation, and I can solve for the y. Makes it super easy. So here we go. Let's distribute. 4 times 15 gives me 60. 4 times minus y gives me minus 4y. Plus 3y equals 38. You can already see where this is going. Let's combine the two y terms. That's going to give me 60 minus y is equal to 38. I'm going to subtract 60 from both sides, and I'm going to get negative y is equal to, what is that, negative 22? Yeah? Okay. So if negative y equals negative 22, we know that y is equal to 22. All right? Good. Now, remember, if I were graphing this, this would be two lines, and they would intersect at a point, and the point has two coordinates. Well, we know that the y coordinate is 22. We need to find out what the x coordinate is. Oh, isn't it nice? We have an equation that says x equals something. X is equal to 15 minus y. And y, I'm going to get rid of this blue line in the way. Y is equal to 22. So that's going to give us x is equal to negative 7. And that is the solution to the system. Now think about this. If we had graphed this, we would have to have a graph where the x would extend to minus 7 and the y would extend to positive 22. I don't want to graph that either. You know, it's nice using the graphing method when the numbers or the intersection is in a nice kind of small frame. But when we get some point like negative 722, that's going to be a really, that's going to be a big graph. So the substitution method, we don't have to graph at all. It just spits out the answer for us. This is the solution to the system. It solves both of those equations. All right? Great job. Let's look at the next one.